Hi again, and welcome back. Alright, so now it's time to get to programming this part. So, first move, we're going to move our steady into place. Okay? Depending on the software you use, this might be a very challenging step. In TopSolid, it's pretty simple. You go to the turning tab, you go to the movement command, turning pull-down menu if you're a pull-down menu guy, or right-click in space, and under turning there, go to movement. Whatever makes you happy. As far as the kind of movement we're doing, I'm going to set that in my quick settings balloon here. Right now it's on a tailstock. I'll double click on that and change it to steady. And now you can see it's already commanding the steady. The software knows the steady is present and it knows what it needs to do. So from here, let's just go set some stuff. So for example, I'm going to say that I want to move this, I don't know, let's say minus 3 inches back. Maybe 4. Let's look at that. That's the center line of my steady from the driven point, which is the center there. Let's just see how that looks. Depending on how you configure your post processor, you might have to do a few more steps in there as far as setting it to open or shut, but here you can see the steady is now in position. It's holding our part. Okay? Next, let's go ahead and do this front facing. But before I do, I'm going to make sure I have a command turned on called Show Machine Preview in Position, and you're going to see why here in a second. With that command turned on, I can come here, and now when I go to my roughing, it's going to show me where the machine is currently at this moment in time. So the steady is in position. It grabbed my first tool from up here, and the tool is just previewing with the stick tool right now. You can have it with the holder if you want, but this is enough. If I put myself in a turning view and look down at this, you can see that I don't have to set the starting position of the tool path. The software has automatically looked at the stock and said, oh, okay, you selected that face, but we're going to extend it out to the extents of the stock automatically. I'm going to say here that, you know what, I don't want to leave any stock. I'm going to machine this just to finish. And I'm going to say my pass depth, we'll say, is 30 thousandths. So you can see it's going to take a couple of passes, finish it. We'll go set our feeds and speeds right away as well, just for fun. I'm going to say that I want to use constant surface footage. And I'm going to be at 850 surface feet, and maybe I want a 10 thousandths chip load. And maybe we're going to turn on the flood coolant on the upper turret. Like that. The machining's done, but more importantly, if you pay attention, the stock has been updated also. Let's have a look. So if I go and roll this back before the roughing, you see there was material here. Now you see the stock is up to date. Moreover, let's do this. Let's simulate what's actually happening. So here we can see that moves in, and here I'm going to pause for a second, turn on the spinning of the spindle. So you see that everything is in motion, in real time, instantaneously, so that you as the programmer know what's going on. Let's keep that going. Let's go here, and you know what? I'm just going to right-click in space. I'm going to go to Drilling, Hole Machining. Now, if I go to Hole Machining, I need to pick a piece of geometry, right? So I'm going to start by just selecting that cylinder, and I'm going to change to be tipping or centering. The software sees that I had a center drill already selected. Okay, I already had that loaded in my set of tools. It's right there. So now we can decide how we want to program this. Okay, we can set a centering depth however you want. You can set it to a fixed value. You can set it to a hard value. You can set it to a driven point if you want. Again, the choice is yours. I'm just going to type in a value and go. And now we're centered. And again, let's watch that simulation. Here we go. Turning. We're going to come back. We're going to index. Ooh, I don't like that. See that movement there? That's called a link movement. I don't like how that approached. Let's see if we can do better. I'm going to right click on this, go to link movements, edit my approach. Here a dialog box is going to pop up, and this software out of the box is trying to be creative with these approach moves. Most softwares, when it comes to movements from tool change to the cut, from one operation to the next with the same tool, or from the cut back to tool change, most softwares solve that in the G-code, in the post processor. So your operators never really know what's going to happen. In TopSolid, we have the link movement editor, which gives your programmer the ability to, movement by movement, control this machine. For example, right now, this first move moves down in X, right? And then moves in Z. Simple enough, let's just put Z first. And then approach in XY, right? So we're moving in Z, then we're moving in XY. That's to the rapid plane, and then we start our machining. Cool. Problem solved in just a few seconds. Okay, next, we're going to continue roughing, but we just want to rough kind of the area above this spline up here. So what I'm going to do, I'm going to select this face as my starting face. I'm going to use the Alt key to say that's my ending face. And this will make sense in 1 second. Once I go there, I'll right mouse button click, go to roughing. Again, you can go to the turning tab, however you want. Because I have show machine preview in position active, the steady's still in position, and you can see now that the toolpath is doing exactly what I asked it to do. It's machining that face up to that face. Great. Now, I want to use the same feeds and speeds that I used over here, right? So I'm just going to simply grab turn roughing here, operation 2, drag and drop it onto my speeds and feeds, and notice if I go in here, it's copied precisely those same feeds and speeds. I can copy anything from any operation to any aspect of any new operation just by simple drag and drop. Maybe here we want to leave 20 thousandths worth of material, and then we want a pass depth, let's say, of 60 thousandths. Okay? Perfect. Green check. Now we've roughed that, and by the way, you can name these operations as you want as well. So I can say rough OD spline, right? Because that's the area that I'm machining right now. From here, I want to finish turn these faces here. So again, select the face, Alt select that face. I'm going to right click, and this time I'm going to go to finishing. Now when I go to finishing, I'm going to switch tools. I'm going to say that I want tool 2 now, right? I'm going to still borrow the same feeds and speeds, because you know what, in all reality, I'm probably going to use the same surface feed, but a different chip load, right? Maybe you'll increase the surface feed a little bit, who knows, okay? But right here you can see, nice arc on, finishing, but you know what, I'm going to extend that past just a little bit, just because it makes me feel good. So I'll go to my lead in, lead out, go to my out, and I'm going to ask for maybe, I don't know, 1/8 inch overlength? Perfect. Just so I make sure those faces are finished. Okay, so moving right along, we've roughed and finished the spline. Let's take care of this groove right away. So I'm just going to right click on the groove, go to my groove command. Okay, my groove tool is on the lower turret. That's another issue, but we'll talk about that in a second. And right now, because it's a simple groove, right, you can see the area of programming that it sees. So it's expecting this rest of this material to be roughed out. It's not roughed out yet, so we're going to be a little bit smarter than the groove. Now we'll come down here. First of all, we're going to ask for a roughing and finishing cycle, and maybe we'll extend that out a little bit, okay, so that it plunges off the part. Perfect. Now, first problem. My groove tool, when I loaded it, is over here. It can't be used because we're using this, the steady, right now. So, no problem. And by the way, what I'm about to show you is a problem in many CAM solutions, but not for us. I'm just going to take this tool holder and I'm going to edit. I'm going to say, you know what? I don't want it on the lower turret. I want it on the upper turret now. So now it's on the upper turret. I can choose wherever I want to put it. Maybe I'm going to put this all the way down there to tool 10. Green check. Of course, this changes the channel it's being programmed on, changes all sorts of things. All I have to do is hit refresh. Okay? And now we're programming with it on the upper turret. So that's perfect. The next problem, if we look at the toolpath, and I'll put myself back in turning view, you can see that it's machining that side face there. So really we're rubbing the tool holder against the stock. Okay, now I can show you collision detection and all that stuff. But one of the things that's super powerful about TopSolid is the fact that you get to see this. You can look. You don't even have to run collision analysis to know that you have a problem. Okay? So here's what we're going to do. I want to go back and change my roughing. Because when I did this roughing, if you recall, under my geometry, I said go from this face to this face, which it did, but I wasn't really thinking through my process, was I? So here, I'm just going to simply go and modify. One of the biggest things in TopSolid that you need to know is that TopSolid, everything is modifiable. I'm going to change my end entity to be this face. Now don't worry, this is going too far, but we're going to fix that. Let's go now to our toolpaths settings. Let's go to stock to leave and limits. I'm going to set this to be in Z, driven by a point, and I'm going to snap back to the center of that same face. But because I told the turning toolpath it's okay to go past that face now, I can go here and say, you know what? Minus a quarter of an inch. Perfect. At the end of the day, a couple things to take away from the things I just did. First, how easy was it to modify the tool holder from my lower turret to the upper turret? Secondly, the modification of the profile of turning was effortless. I didn't have to go draw something new. All I did was change my chaining, update a few things, and I'm off and running. This took a few seconds of work, not minutes or hours, right? Let's regenerate. We're now ready for the next step. All right, so now we've done all the turning we can for the spline, right, in the front of this part. So now what I want to do is I want to machine the spline. Simple enough. So let's go here. I'm going to select one of the faces of one of the splines, and under 2D milling, because that's what this is, I'm just going to go to others and I'm going to do slot milling. Okay? Now, here the software automatically grabbed my first mill that is in my upper turret. My first end mill happens to be the right tool. Okay, but it's just because it was the first one in the list. Again, we'll set some feeds and speeds. Maybe we're going to run this at 5,000 RPM, and maybe we want a chip load of maybe 2.5 thousandths. Again, we want that flood coolant on, right? Next, I'm going to turn on take into consideration the stock so that you can see it's only machining where the stock is. From there, I don't need to do slope. I'm going to do zigzag step, and maybe let's set our zigzag step to be 30 thousandths. And you can see the tool is going to come in and it's going to come over, plunge down, come over, plunge down, and so forth, so on, and machine our steps, right? Now, we'll click OK. Beautiful. Slot machined. Next, I'm going to simply select the WCS for that operation and do what we call a WCS repetition. Okay? See, it's got the slot milling. I'm going to say I want a circular pattern about my absolute Z. 360 degrees by how many of these things? Well, let's see if we can figure that out. 360, what if I said there's 20? That might be the right number, I'm not sure. So let's go set our starting point to be right here and see. And you can see every instance looks like it's on the center of my spline appropriately. Okay, so I can click OK. Here you can see all of the toolpaths. We're going to green check. And now we just have to calculate them. So now it's going to update the stock for each of those moves. And we've created 20 different toolpaths. Yeah, 20 of the same toolpaths, but very quickly and fairly effortlessly. And again, and I'll turn off my finish part so you can see this, you can see the in-process stock update. It's telling us that we've done a good job. Okay? Right. So next, we're going to take a pause of programming and look at our scenario. Okay, first of all, what is this scenario? So I'm going to switch to our machining final stage. Remember, this is a multi-channel machine. And by multi-channel, we have an upper turret and lower turret, and they have to kind of handshake and tell each other what they're doing so that bad things don't happen, right? So first, you can see majority of my programming is on the upper channel. That's fine. But right now we have an error down there. It's kind of hard to see, so I'm going to put myself in constant display mode. The difference being, in constant display mode, it shows every operation at the same cycle length, but it makes it easy to see what you're looking at. Whereas if you turn this off, everything is based off of real cycle times. So you know what's going to take a long time to machine versus a short time to machine. Okay? The other advantage, if I zoom up on this stuff so you can see it, is when you're in this mode, this constant display mode, you see we're coming from tool change. This is the link movement, this is the cut, this is the retract movement, this is the tool change again. Okay? Now, right now, both of these cannot run at the same time. Right? This is the roughing of this face if I zoom up, and this is the movement of the steady. So we have to add a synchronization point. Lots of ways to do it. I like automatic, so I'm going to right click here in my scenario and just hit automatic. With automatic synchronization, it's not rocket science. What we're doing is we're just adding the synchronizations based on the order you've programmed your operations. For new users, this is fantastic because it is very safe. Beyond that, if you want to do things manually, you can add the alignment tool here and you can choose to sync wherever you want to sync. Okay? Now, that's done. Let's maybe have a look at verification as well. So now we're synchronized. So I'm going to make sure my verify mode is on here. I'm going to hit play. It's going to take a second as it spools up verify. Verify is again integrated inside of TopSolid. And you can see right away it goes directly into machining. And here we go. Maybe we'll speed up this a little bit. Zoom up, rotate. You can always pan, zoom, do whatever you want. If you want to skip to the next move, you can just hit the divide key on your keyboard. So if I hit that really fast, you can see it's just skipping right through. Here's our finishing turning. Here's our grooving. And now we're machining the slots. You can see, nice, beautiful machining. And I can speed through this even. And the verification is done. Exit out of that. We'll eject out of our verify. We'll switch back to our programming mode, and then we'll continue programming the next features. All right, so next what we're going to do is we're going to move the tailstock into position. Okay, once the tailstock's in position, then we can pull the lower turret back out, and we can start using the lower turret at the same time. So let's see how that works. Again, I'm going to right-click in space. I'm under my turning section. I'm going to go to others. This is a movement. I do want to control my tailstock. I'm going to activate a tool selection, and I'm going to make sure that we go and select. Actually, I don't need to activate tool selection, sorry. Every machine definition is slightly different. This one doesn't need one. I'm going to go here, and we're going to move to a point, okay? And the point is going to be right there. I'm just literally selecting the cone so it drives the tip of my tailstock right there to there. Now, you can see there's a yellow move there. That yellow move is a feed move. So I'm going to go in here and say that maybe I want 25 inches a minute. Go to my settings. I'm going to say my approach is going to be maybe 1 inch out. So I'm going to rapid to here and then feed it 25 inches a minute into that final position. Let's see how that looks. Come on down. We'll run our simulation. Boom. I don't know if you saw that, but this moved in and then the quill moved in at the last second there. Let's do it again. Maybe we'll slow it down some. Here's the quill. So now we're in position. Now we can retract that out. Okay, so now that we have the tailstock in position, now we're going to disengage the steady and get this tool ready for the next operation. And to do that, we're going to do something called a virtual jog. So virtual jogs can be really, really handy. Think of them as MDI mode on the machine on steroids full of chocolatey goodness, because you can just tell the machine to do whatever you want it to do. For example, I'm going to go here, and I'm just going to do machine axis motion. And in my X2, I'm going to say, let's go to minus 8.6 inches. And you can see we've gone down almost to the maximum stroke of the machine. I'm going to green check that. And then I'm going to index the turret, pick my turret, and I'm going to choose the tool that's in pocket 5. Green check that. And I'm done. That's my move. Okay? I'm going to rename this. Steady retract. Tool index. For right now. And we'll hit save. And in the next operation, we are going to use 2 spindles, or pardon me, the 2 turrets to rough the length of this part. But before we do that, let's just simulate this one more time. Perfect. Looks great. Okay, let's get to roughing the length of the part here. To do that, I'm going to go ahead and just zoom up a little bit. We'll select this face. I'm going to use the Alt key plus the left click to select the end condition. And the Alt selection, again, just as a reminder, says to TopSolid, I want to machine from here to here. Next, I'll right click, again, go to roughing. It's going to pick a tool for me. I don't want that tool. I want to be my upper turret with tool 1. Perfect. Maybe we want to use the same feeds and speeds as our initial roughing. Awesome. And then maybe we want to leave, I don't know, 20 thousandths worth of material for finishing and a 60 thousandths depth of cut. And now if we look, that looks really nice. And now from here, if we look, this is machining all the way to almost the jaws of your chuck. And notice it's automatically stopping, and it does that because at TopSolid we understand you don't like that loud thump 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 on your machine. Joking aside, let's look how we can control that a little better. So if we go into our toolpath settings, go to stock to lever limits, you can see the limit definition method is by default set to chuck jaw. I can use my safety distance right here to control how far away from those chuck jaws we are. Let's say, for example, I wanted this to be 1 inch. You can see dynamically it updates in real time. Maybe I only want that to be 1/8 of an inch. Great, whatever you want, you can control within the solution. Let's validate, let's see what that looks like. You can see it, of course, it updates the stock. And if I come down here and I run the simulation, looks good, right? But looking at this, I think we can do better. And how are we going to do better? Well, simple. Let's use roughing on 2 turrets instead. So in some softwares, they call this pinch turning. In TopSolid, we call it roughing on 2 turrets. And the way this works is quite simple. You edit the roughing you just did. You go to the toolpath settings. And here, you have an option called roughing with 2 turrets. We're going to activate that option. Very first thing we need to do is select a tool. So we'll go to select a tool. It's automatically going to point you to the other turret, which is fantastic. We're going to select our other tool. The only rule here is the other tool has to have the same nose radius. Like that. And then finally, how do we want to do this? Do we want to do passes divided by 2 or feed rates are multiplied by 2? If we do passes divided by 2, typically there's an offset between passes. So the lower turret will be trailing the upper turret by X amount. In this case, I'm going to put a 1/2 inch just so that you can see what's going on. That's it. Green check. Once those operations are created, and you can see now it has an operation here and it has an operation here. Let's go back to our machining final stage. And here you can see the synchronizations have automatically been created. We're going to do automatic layout just to make sure. Everything looks good to me. And if you recall, if we go back to this mode, you can start the simulation wherever you want to start the simulation. So I'm going to start the simulation maybe right there. We'll hit play. So this is the finishing of those slots, right? Maybe we'll fast forward just a little bit. Here's the tailstock coming in. And now let's take a look at the pinch turning. Speed that up just a wee bit. And you can see, if I pause it here, you can see that's trailing by about 1/2 of an inch. It's going to wait there. The thing about the roughing with 2 turrets is the synchronizations are done automatically by the algorithm. So really all you have to do is choose to use it. It doesn't get easier. Alright, so let's go ahead and finish our turning operations. So again, I'm going to select this face. I'm going to alt select this face here. And I'm going to go to finishing. We're going to go ahead and switch tools now. I'm going to say that I want to be on the upper turret. And I want T2. Great. Now, first of all, you're going to see that it doesn't want to get down there, right? And it's just because it thinks that it would have to plunge to do that. So let's turn on pocket plunge, see what happens. And it does. So now it's coming down below, it's leading on, but now we're doing this, which is not at all what we want. So this is now where some softwares that try to do solid-based programming make you draw custom profiles and things like that. And I just want to point out to this point, we've drawn nothing. We've worked directly on the solid, which is fantastic. So in TopSolid, we want to make it as simple as possible. So you have a couple ways when dealing with pocket plunges to control them. First, I can just pick the pocket to ignore it. Select the face and notice it goes straight over the top. If you don't want to do that, you can set what the minimum pocket width needs to be. Here I'm going to say it's 1/2 inch. And now notice, we plunge, we plunge, we plunge. Okay, here that's wider. Maybe we don't want that at all. So let's say, how about 0.75? Awesome. And like that, we've now finished turning that profile. Cool. Next, I'm going to say that I want to machine, and here I'm using Control to select multiples, right? I want to machine those slots. So I'm going to right click, go to Groove, There's all of our grooving toolpath. Again, you can set your feeds and speeds as you want. I'm going to use the same feeds and speeds as my general roughing. Maybe I'll come into the operation and tell it to do roughing and finishing. Great. And then lastly, I'm going to use control drag and drop. Grab this one. Okay. And this one, because it sees the radius there, it wants to machine the radius as well. And we're going to say that, you know what, we don't want to do that. So we'll go to our settings, to our geometry, turn off topology mode, and I'm just going to tell it to do nothing for that. Great. Like that, all of our turning is now complete. All right, now that we're done with turning, let's go ahead and begin our milling operations. So let's start by having a look here. What do we got going on? Now, first thing, just to point out, you see some profiles here. This is the spun profile that the software automatically creates. If you ever want to turn that off, you can go to your Entities Manager and just uncheck spun profiles. That way you're not looking at it, right? From here, maybe we want to start by machining this face. So let's select it, and let's go to end milling. Great. Maybe instead of using the 1/4 inch tool, let's use our 1/2 inch end mill. That looks a little bit nicer. If you are a adaptive roughing strategy type of programmer, we can even use boost milling if you like. So I'm going to say I'm going to run this at 5,000 RPM, and I want maybe a 3,000th chip load. Again, we want our coolant, right? And then from there, what I'm going to do is I'm going to say that I want to do this as 1 depth of cut because we can. Okay. I'm going to say that I want a 10% engagement, and then I'm going to activate boost. And boost milling is looking to maintain, oops, sorry, missed it. Boost milling is looking to maintain chip load and feed rate. So it's going to vary the feed rate to maintain chip load. It's going to maintain exactly 10% or less of a cutter engagement. And if we look here, you can see that it's inserting additional passes in the corners so we don't overload. And when you see the pinkish toolpath, it's also varying the feed rate. The dark blue is max machine feed. So now we're just nibbling away. Let's maybe add its cousin over there. Great. And we're going to say the stock to leave on the floor. I'm just going to go to 0 since it's just a demo, but on the wall, maybe we'll leave 20 thousandths. And we'll come back and finish that with a finishing pass. And like that, we've now roughed out those slots. Next, let's take that WCS and do a repetition on it. My repetition, I'm just going to borrow from the TopSolid design. Notice if I click here, I can hover over this. This part was designed in TopSolid, so we know the repetition exists. So we can just borrow the same repetition. This is going to repeat the open pocketing that we want, but there's also a slot milling that's on the same WCS over here that we don't want. So I'm going to uncheck that. Green check, regenerate, and we've now roughed out all of those slots around the part. And if you want, we can just take those and go into verification with it, and we can have a look. So we'll hit play. Tool's going to come over, and now you can see we're doing the nibbling with the side of the cutter, and off we go. Let me speed this up some. You can see it's pre-positioning nicely, and we've roughed out those open pockets. Okay, now that we've roughed out those pockets, let's now take on these angled faces. So on this machine, it's the upper turret has an XYZ axis, the lower turret has an XZ axis, but we don't have a fifth axis to be able to machine that face. Now, we could rotate it and cut with the side of an end mill, provided you have enough Y-axis stroke, right? But instead, we're going to show you how to use a custom angle head. Okay? Now, first thing to note is I have some custom angle heads that I've put into this project. It is a custom machine component, This angle head allows you to dynamically set whatever angle you want to use the holder at. Okay? The way it works is quite simple. Zoom out here a little bit. We're going to look at our upper turret because that's where we're going to put this thing. Let's grab our angle head, drag and drop it into a pocket. Maybe I'll put it down here. Okay? And when I do that, I'm going to set this to maybe 30 degrees because I think that's the angle that the part is at. New positioning, green check, perfect. Now, from here, that's just the tool holder. Now we need to put a tool in there, right? So I'm going to go to my equipment tab, and in this case, I'm going to do something a little bit different. First of all, let's identify the upper turret. Let's go down and find this thing. Here it is. I'm going to build a tool on the fly. So far, I've been grabbing tools out of the library, and that's great, but I just want to show you how easy it is to build a simple stick tool. By default, when you choose to build a tool on the fly, it pulls from a template. I'm going to change it to just be the stick tool. Okay? And then from there, I'm going to choose to make a stick tool that's got an angular relief on it. So I'm going to set the shank diameter to maybe 3/4 of an inch. And then down here, this will be a half. This will be a half. I'm going to say it's 1 inch of flute. Maybe it's an 1 1/8 to here. Maybe it's 1 1/4 to there. And maybe overall it's a 3-inch tool, right? Maybe this is bigger. Maybe it's 1 3/8. Oops, pardon me. 1.375. There we go. Now you have your angle. And then, of course, you can go to the tool assembly and you can play with the gauge distance of the tool all you want. I'm going to say this tool is sticking out 1 3/4 by default. Green check. Now we have our tool. Let's go ahead, validate that, and let's see how it's used. So I'm going to go back, zoom up on my angled face, and right click, go to end milling, and I'm going to go and try to select my angle head tool. And once I do, you can see it is showing the tool in the angle I've set, but as it turns out, I've set the wrong angle. And my WCS solution here is telling you that WCS orientation is not compatible with the given geometric constraints. It means that the tool that I've selected cannot machine perpendicular to that face, and it's because we've set the wrong angle. Now, I'm going to escape out of that, and let's talk about how you can measure angles. It's quite simple. Go to Analysis, go to your little calipers there, set yourself to angle, select faces you want to measure off of, and there's our angle, 20 degrees. So, how do we fix that? Again, as you've heard me say in other parts of this demonstration, everything in TopSolid is modifiable. So I'm going to right-click on my holder, go to Edit, here's that value. I'm going to set it to 20. You can see it just rotated. Green check. Awesome. Now we're ready to program. Let's go back and zoom up. Again, end milling. Let's go grab the tool from that pocket. That's correct. Right there. You're going to see that we have tool path, right? Now, a couple things I'm going to change about the tool path. First, I don't need to take such shallow depth of cuts. Okay, I'm going to say that my depth of cut is going to be 1/4 inch. Great. Next, you can see I am cutting air right now. Okay, and you know, I suppose you can do that, but that's not what you want. You want it to just machine where there's material. So thankfully, TopSolid's got your back. You have something in 2D milling and in turning called Z-Path stock fitting, where it just fits the tool path to the stock at every depth of cut. Therefore, you are now only cutting where there's actually material. Now, the rapid planes it picked were rapid planes based on the angular solution we're on to the highest point from the part. Okay, we don't need to wrap it that high, so let's go to our altitudes. And let's start with changing the altitudes per region to be an incremental value. Okay, and I'm going to set that at maybe 1 inch. I'm going to set my clearance altitude between cuts to an incremental value of maybe 1/4 inch. And then I'm going to set my final altitude to an incremental value, and we're going to set that at maybe inch as well. And maybe my start value, I'm going to set at 1 inch also. Okay? And it's just changing your start rapid planes so that we're a bit closer to the part. Like that, we're going to green check. And then just for fun, let's go take this and simulate it once. And you can see right now the approach is, well, it's no good because it's going to over travel the machine. Again, we're doing something kind of not standard on a machine like this. We're taking our angle head, so the software is trying to do its best in automatic mode. Can't figure out that link movement, so let's go here and edit that. Again, TopSolid is, I want to say, one of the only, if not one of the few, that allows the users full control of these movements. So turn off automatic mode. I'll flip this over to here. Right now, this is approaching in C, which is perfect. And now this one is just approaching in XY, and what we're going to do is tell it to approach in XY and Z at the same time. So let's try it. There's C, and there's XYZ. Perfect. We don't need this move anymore. Doesn't do anything, and we're done. All right. And finally, let's go look at this in Verify, just so that you can see it go in. Sorry, didn't mean it to be that fast. Let's rewind. Go again. I'm just going to skip through those first few moves and zoom up. And here you're seeing it's doing what it's supposed to do. TopSolid makes anything relatively simple. Okay, so let's do one more operation before we call this done. Just to save some time, I already preloaded another copy of our angle head. Put a 1/4" drill in there to do these drillings. Okay, so let's go ahead and select, and I'm using control there. We'll go to drilling, we'll just do hole machining. It found my twist drill already since it was preloaded. About the only thing that maybe we want to do is change the starting altitude. Again, maybe we'll go here. Oh, we'll set the starting altitude to be there. That's perfect. Final altitude, we'll set it to a value. Maybe we'll set this as 1. -2, let's see, there we go. We want it down here, because again, our 0 reference is out there. And between holes, let's go to a value as well. And we'll set this one to -1. Okay, so now we should be okay. And if we simulate, and by the way, let me back up. Notice because I did the repetition on this facing, on that WCS, it automatically did the repetition down here. I just have to regenerate. And then we can simulate. Here it comes. Drilling's done. Alright, so now that we've done most of our programming, I'm skipping these slots for now, but let's go ahead, switch to that final stage. Let's check our automatic layout one more time just to make sure it's good, looks okay, and let's do that final step. Let's generate some G-code. So here I'm going to grab an LU3000 post. We're going to hit generate G-code, we'll hit save and go. See, it's crunching everything out for us. And like that, here's the posted code. You can see a basic tool list up front, and as we scroll through, here's your G-code to run on the machine. Now, for the turning operations, you can see I'm using straight code. You have the choice to use turning cycles as well, or roughing cycles. You just have to choose to activate those inside each of the operations where you would rather have a cycle. Okay? But if we scroll down to some of these things, here's our slot milling, the indexing, going. Maybe let's go find our angle head operation. That was tool 11, right? So let's go find tool 11, right? Here we go. This is with the angle head, right? And off we go. Now, if your machine supports G68 for plane rotation, we could output these coordinates in plane rotation. But you have to make sure that your machine supports those cycles and let us know so we can figure your post-processor correctly for you. Other than that, you have your point-to-point code for all those operations. Off you go.